All right, our next chapter is chapter 20. Chapter 20 is really exactly the same as chapters 17 through 19. The material will be exactly the same. The only difference is instead of finding a confidence interval or hypothesis test for one proportion or one mean, we're going to do a difference of two proportions and a difference of two means. So really, the only difference becomes, for example, for proportions, we're still going to go to proportion stats on StatCrunch. Um, we're still going to do with summary. We're still going to do hypothesis test or confidence interval. The difference being that we're going to do two samples instead of one sample. And same thing with means. We'll still go to t-stats, but we'll choose two sample instead of one sample. So I have a few examples here, complete with screenshots. So let's just kind of go through these examples so you can see how this works. So here's our first example. So a news organization randomly surveyed senior citizens and asked them whether they had some form of arthritis or not. The results found 547 of 1,064 women and 401 of 1,009 men suffered from arthritis. Create a 95% confidence interval for the difference P1 minus P2, where sample 1 is the proportion of senior women and sample 2 is the proportion of senior men. So again, this is a proportion, a percentage. So I did this on StatCrunch. So I went to stat, proportion stats, two sample instead of one sample, and then with summary. And you can see I put in here, sample one, they said was the proportion of women. So 500, and actually I made a mistake here. There's a typo. That should say 574 of 1,064. So I'm going to change that right here, right now, so you don't get confused. So 574 of 1,064 women, and then 401 out of 1,009 men. Right, sample two was the proportion of senior men, and we wanted to do a confidence interval with a level of 95%. So I put in 0.95. I then went to compute, and this is what it gave me. Okay. So remember, with confidence intervals, we look at the lower limit and the upper limit. All right. So 0.074 and 0.159. Okay. So what this means is that we are 95% confident that the percentage of senior women suffering from arthritis is between 7.4 and 15.9% more than the percentage of senior men. Notice the proportion, the confidence interval is for the difference. So because the difference is positive, that tells me that sample one has to be larger than sample two. And remember, problem is that sample one was women, sample two was men. So we are 95% confident that the percentage of senior women suffering from arthritis is between 7.4 and 15.9% more than the percentage of senior men. Okay, more because that difference was positive. Okay. Here's a look at example two. A medical office randomly surveyed women with children. They reported 48 live births to 161 younger women, but only 6 live births for 91 older women, meaning over the age of 40. Is there evidence of a difference in the live birth rate of younger versus older women? Okay. So in this case, notice it did not specify. It did not specify which one was sample 1 and which one was sample 2. So when I went to StatCrunch, okay, and I did this again on StatCrunch, stat proportion stats to sample with summary. So when I did that, I just chose to do younger women for sample 1 since that's what was mentioned first. And then I did older women for sample 2. Okay. Older women for sample 2. So that's what I did here. And I wanted to do a hypothesis test. Is there evidence of a difference in the live birth rate of younger versus older women? Notice this does not imply less than or greater than. So because it doesn't imply less than or greater than, notice when I went to hypothesis tests, okay, notice I chose not equal to. All right. And when I did that, notice I got a p-value of less than 0.0001. So 0.0001, is that less than 5%? And of course, yes, it is. So the p-value is less than 5%. Okay. So what does that mean? If you look back to your notes from chapters 17 through 19, if the p-value is less than 5%, that means that my null hypothesis, my initial guess, is false, which means the alternative guess, the alternative hypothesis, is true. So in this case, this part here, where the difference is equal to 0, that is false, but the difference not being equal to 0, that is true. Okay, so we are saying that the difference is not equal to 0. That means there is a difference between younger and older women. So there is a difference in the clinic's methods for older women because our alternative is true. Okay. Let's look at example 3 now. We got 2 more examples left. A CEO moves to a new city. He sees that there are 2 potential routes he could take to work. To decide which route is quicker, he drives each one for 15 days. He finds that Route A takes an average of 47 minutes with a standard deviation of 1 minute. Route B takes an average of 52 minutes with a standard deviation of 3 minutes. Find a 90% confidence interval for the difference between Route B and Route A. All right, so for this one, let me go back to the beginning here, the first slide. For this one, we are doing the difference between 2 means because we are looking for, okay, we are looking for the difference in which one takes a shorter average time. Okay, but notice in this case it says the difference between Route B and Route A. So when I do that, when I go to stat and I go to T-stats to sample with summary, notice I put Route B as sample 1. Because the question said the difference between Route B and Route A, that means Route B has to be sample 1 and Route A has to be sample 2. Okay, so when I put that information in, I put the mean and the standard deviation for Route B in sample 1, and then the mean and the standard deviation for Route A in sample 2. Notice under the sample size, I put 15. Why did I put 15? Because it says he drove each route for 15 days. Okay. So I chose a confidence interval, and it looks like my screenshot got cut off here, but I chose confidence interval, and I put in 0.90 for the confidence level because it said a 90% confidence interval, and I got this right here. Okay, so we are 90% confident. So here's our lower limit. Here's my upper limit. So we are 90% confident that the actual difference between Route B and Route A commuting times is between 3.58 and 6.42. So if I was to take the actual average time for Route B and Route A and subtract them, that difference would be somewhere between 3.5 minutes and 6.4 minutes. Okay, so we are 90% confident, that the actual difference is within that interval there. Okay. Last example below is data collected on the mortality rate in two different regions of the country. Is this data evidence that the mortality rate is significantly different for the two regions? Okay, so once again, in this particular case, it didn't specify whether A or B was sample 1 or sample 2. So I just put the information for sample A, for region A, in sample 1. All right, so again, I went stats, t-stats, to sample with summary, and I put in the mean, I put in the standard deviation, the count is the sample size. Notice the median didn't matter. That was just useless information they threw in the problem to try to throw you off. Okay, and then I put the difference or the information for region B in sample 2. All right, so mean, standard deviation, and then again, the count is the sample size. And I went to hypothesis test. And again, the question is this data evidence that the mortality rate is significantly different for the two regions? It doesn't specify greater than or less than. So again, in this drop-down menu here, I chose not equal to. And when I did that, I got a p-value of 0.0016. Okay, so once again, with our p-value, because our p-value is less than 0.05, because it's less than 5%, that means the initial guess is false. So that there being no difference, okay, the difference being 0, okay, that is false, and thus this is true. So the difference is not equal to 0, meaning there is a difference. Okay, so in context, that means the mortality rate is significantly different for the two regions because the difference is greater than or equal to, or because the difference is not equal to 0. Okay, that is it for the PowerPoint. Your Math Excel assignment for this chapter will be a few examples, literally just like the ones I just did. So if you follow along with this, you should be able to do the Math Excel assignment for this chapter. Obviously, reach out to me if you have any questions.